Okay, hi there, Year 11s. I'm doing 7A question 2, part F. Here's the statement about set A. It's saying this set A is equal to the set of x values. Now the x values are real numbers. Okay, so these elements, x's, belong to the set of real numbers. They lie between 3 and 5, including 5 but not including 3. And this symbol here is union, right? It means we can combine this with x values greater than 7, all right? Now this union symbol, I find it easiest to picture on a Venn diagram actually. Imagine you had two sets, A and B. If you wanted to show what A union B looked like, it's just everything, right? It's combining A and B, as opposed to intersection, which looks like this. We'd only be looking at, right, where do you get both? This is in probability. We could say we could think of this as like a and statement. Would be, imagine a probability question. What's the probability that you have A and also B, right? You could represent that and as a intersection. All right. For the union statement, what am I trying to do? Erase. Go back to the symbol we've got, the union. A union B. It's like I've got this whole space. I can be in A or B. So you might have some different ways of thinking about that. For example, probability questions, right? Okay, so part 1, we've got to write this as a sentence. Let's try and do that quickly. The set of, we have real numbers, we're calling those numbers x, such that x lies between 3 and 5, including 5. It's not including 3, you could write that. As well as, or we might just say, and x is greater than 7. I could write but not including 7, but the greater than, which I said greater that, sorry, that should be a than, greater than 7. That statement implies that we are not including the 7, right? So it's okay just to leave it like that, as opposed to greater than or equal to, right? No, we'll leave that up, right? So part 2 is list the elements. List all the elements. Impossible, not possible. Why is it not possible to list them all? Impossible, because they are infinite, right? So x has infinite values, real numbers. All right, real numbers includes all rational and irrational numbers in between the integers and the integers themselves. right? So there's just an infinite amount to list, so it cannot be done. All right, you would be there for an infinite amount of time trying to list all those numbers. All right, find the number of elements. Again, I can't do that. So n of a, well, it's just infinite, right? Too many. I can represent this on a number line though. So let's draw another line. All right, our numbers are going from 3 to 5. Maybe if I start at 0. 0, 1, 2, 3, 4, 5. I need to be going greater than 7. Or maybe I'll go up to 9 or something. Just a few numbers higher. That'll do. One more for good measure. Okay, how do I represent x lies between 3 and 5 but only includes 5? This is important. You need a dot coloured in for that 5 because we include the 5, but for the 3 we want an open dot. So that's how we are representing that we're including the 5 but we're not including the 3. Now x greater than 7, so we're not including the 7, and then we're going up here to infinity and beyond. Okay, thank you.